Church numerals. Let's examine a bit how church numerals work. The expression I've done here is 2g, where 2 is just the number 2. So the number 2 is represented as lambda f dot lambda x dot f applied to x. You have to be careful with these parentheses here because you only want the f to apply to the x. You don't want f applied to f and then the result applied to x. You want to apply f to x and then apply that result to f. Now, in this case, g is just a free variable, so when I substitute g in for the function here, we just get lambda x dot g x. And this is why 2 is really twice. What 2 means in church numerals is do it twice, apply the g function twice. Let's make sure that still follows when instead we do addition. Let's add 2 and 2. This is the definition of add from the notes, lambda m dot lambda n dot. Now we're going to create a number, so lambda f dot lambda x. All numbers in church numerals are functions of 2 arguments. Then m applied to f, applied to the result of n applied to f, applied to x. Remember, church numerals are n many or m many times, so twice. So if I apply the church numeral m to some unknown function f, what that means is do the function f m many times. Similarly, do the function f n many times. Now, the next reduction we can do is to replace 2. Apologies, this is going a bit off-screen, and we'll go even further off-screen in a moment, but 2 is simply lambda f dot lambda x dot twice, ffx. Now we substitute that 2 in this application for the m. So down here, m has been replaced with lambda f dot lambda x dot ffx. This is why we had to be careful about renaming, because this f and this f are not the same f. This is the f of the number we are producing, here labeled f3, and this is the f of our first input argument, here labeled f7. It is because of this difference that we have to apply one f to the other, which is to say, replace the f of the number that we are inputting, the number that is our argument, with the f of the number that we are producing. So when we swap f7 for f3 in this number, now we'll get lambda x dot ffx. f3, f3, so these are the correct f out here. But we still haven't handled x. X is what we're applying those f's to. If we wanted to add 2 and 2, then, well, what we want to apply the f's to is the result of that second 2, the rest of the addition. And indeed, when we do this application, x is abstractly what we want to apply the addition to. So this gets substituted in, and now we have 2 plus whatever n is going to be. N is going to repeat this f the correct number of times, and then we do f 2 more times into the number we're actually producing. So we substituted the f in this original number for the f we're producing, but we substituted the x, which is the core thing that you're going to apply f to that many times, with the other number. So, 2, then 2 more. 2, then 2 more. At this point, there's nothing else that can be expanded here, but we haven't quite finished adding. We still have to substitute n. So we are going to expand the 2. The 2 expands exactly the same, slightly different naming. In this case, it happens to be f9 and x10. When we swap this in for the n all the way in there, so here's our definition of n, and here's our use. We'll swap the number 2 in for n there. Now we have a number in the middle here, but we're going to apply that to our f, the f of the number we're producing. Again, we have the f of the number we're consuming, f11, and the f of the number we're producing, f3. But the way you apply is substitution, so we'll just replace one f with the other. So this f11 will be replaced with this f3. Now that f3 is in place here. Now the only issue is we have this abstract x, the thing that we're going to be applying the number to, and this abstract x, also the thing we're going to be applying the number to. We want them all to be the same x, the x of the type we're returning, but once again we simply need to substitute. Replace the x in the number we consumed with the x in the number we're producing. So replace x12 here with x4, which corresponds to here. After that substitution, we have lambda f dot lambda x dot f paren f paren f paren f x, and then the correct number of ending parentheses. So you can see that just by substituting things into the right place, we ended up getting these two f's from the first two, and these two f's from the second two, and thus we've turned 2 and 2 into 4, or twice and twice into 4 times. All that church numerals are is repeat this function this many times, and that's what we've accomplished. The f function is repeated 4 times. 2 plus 2 is 4.